All right, hello and welcome. In this video, we're going to be looking at multiplying polynomials. So this is similar to what we were doing last time with the adding and subtracting. The only major difference here is that when we are multiplying polynomials, instead of only combining the like terms, right, each term from one set must distribute to both terms of the second set. And so the easiest way to do this and kind of keep everything organized is to set up a little box or a grid that looks like almost like the matrix that we were working with in the previous section. So what I'm going to do is take the x plus 8, and instead of writing it going across, I'm going to write it going up and down. And then instead of the x plus 5 right next to it, I'm going to put the x plus 5 just sort of on top of my little box. So we can visualize my box just going like right here. And so what we're going to do is first distribute the x to the x plus 5. So x times x gives me x to the power of 2. X times 5 gives me positive 5x. Then I'm going to do the same thing, but instead of the x, I'm going to distribute the 8. So 8 and x multiply to 8x. And then positive 8 and positive 5 multiply to 40. And so what I should notice now is that the inside of my box forms something similar to what we did in the previous video. So to simplify this, I will simply combine my like terms. So the x squared does not match with any other terms, so my x squared will come out. My 5x, however, is a common term with my 8x. So if I do 5 plus 8, that's going to give me 13x. And then the 40 is not common to anything else, so just like the x squared, it's just going to come out. All right, so for our second example, we're going to look at x plus 6 times x minus 6. So once again, I'm going to take whatever the first set is and write it going vertically. And then I'm going to take whatever the second set is and write it horizontally. And then once again, I'm going to distribute the numbers on the outside to the numbers on top. So my x and x make x squared. X and negative 6 multiply to negative 6x. When I go to the bottom row, I'm going to get 6 and x to give me 6x. And then positive 6 and negative 6 will make negative 36. To get my final answer, my x squared is the only x squared inside the brackets. The negative 6 and positive 6 add to 0, so those cancel out. And then the negative 36 is by itself because there's no other terms that are only constants. So for our third example, we're going to look at 3x minus 2 squared. So whenever we see the exponent of 2, we need to remember that that really means that we want to multiply 2 copies of the same thing. So my second set is just going to be 3x minus 2 again. And so from here, we're going to set up our multiplication just like we did before. So 3x minus 2 goes up and down. And then the second 3x minus 2 goes on top. There's my box. And so we'll multiply. So 3x times 3x will give me 9x squared. 3x times a negative 2 will give me a negative 6x. Negative 2 times 3 will give me a negative 6x again. And then negative 2 times negative 2 gives me a positive 4. So as we've seen before, the x squared does not match with anything else, so the 9x squared will come out. If I see negative 6 minus 6, the x's will combine to negative 12x. And then finally, the plus 4 is the only number by itself, so we will just bring that guy out. So in this example, even though I only have one term outside the parentheses, I can still set it up in the same way. So I'll bring my 5x squared down, leave my 6x minus 2 on top, and then make a little box that's only going to have one row. So when I multiply the 5x and the 5x squared and the 6x, I should get 30 x to the power of 3 because I took 2 copies of x from the left and combined them with a 1 copy of x on the top, which would then give me 3 copies of x. And then for the second term, 5 times negative 2 will give me negative 10. And then the x squared carries over because the negative 2 didn't have any x's on it. Since none of the terms in the row are common to each other, then 30x cubed minus 10x squared is our answer. All right, and so for our final example, we're just going to kind of put everything together. So I've got a minus b squared times a plus b. And so we remember that the exponent means I need an extra copy of the first set. So we're going to need an extra a minus b. And then from here, since I can't make a box with 3 rows or 3 columns, like it's not going to work with 3 sets, what I'm going to do is just take basically 2 sets at a time. So I'm going to focus on these 2 first. So I will have a minus b going down and a second a minus b on top. So once again, we'll distribute. We'll get a squared minus ab minus ab again and then plus b squared. So when I combine this set, I get a squared minus 2ab plus b squared. And then I will take that and multiply it with the a plus b that we have left over. So when we're multiplying a set of 3 times a set of 2, it's still going to work the same way. I'm just going to leave the 3 going across the top. So I'll have the a squared minus 2ab plus b squared. And then on the left side, we'll just carry down the a plus b. And then we'll do what we did in the previous set. So I'll have a cubed minus 2a squared b plus ab squared. And then on the bottom row, I will have a squared b minus 2ab squared plus b to the power of 3. So now to combine these, we need to remember what we talked about earlier about the variables and exponents having to match. So as I'm looking through my set inside the box, I notice the a cubed doesn't combine with anything. For the other sets, what we should notice is that the ones that are like terms are going to be diagonal to each other. So I see a negative 2ab squared and a positive 1ab squared. So if I do negative 2 plus 1, it gives me a negative 1. So I should see negative 1a squared b plus, then I see plus ab squared minus 2ab squared. So that's another minus 1. And then finally, the b cubed is by itself. All right, that's all I have for this one. I will see you guys next time.